Hello, today we're going to talk about chemical bonding. Alright, the first thing we're going to talk about is electron configuration in each element. So here I have calcium. It's number 20, its atomic number is 20, so there's 20 protons, 20 neutrons in the nucleus. And then it's surrounded by these circles. These circles out here are called orbitals. Alright, so each of these orbitals is filled with electrons. As they go up, they're also called energy levels. So the first one has 2, 8, 8. So the last one on the outside is what is called your valence level, or valence shell level. It calls it level in this, but I've always heard it called valence shell. So on that outside, it's the outermost shell, is your valence shell. It wants to have 11, it wants to have 8 electrons in it. So that's what each one of these orbitals has. It has electrons in it. So all these circles are just contained with electrons. In this case, there is 2 electrons on the outside. What it wants on the outside is a perfect octet, or 8 electrons. This doesn't, so it's not as stable. It wants 8 to become stable. So this is how it looks in the lessons. So you have your atomic number. I didn't put the atomic weight on here. But then on the side of the element, it has each shell. So this shows that there's 4 shells, or 4 orbitals. And you have 2, 8, 8, and 2 electrons in it. So the third one has 8, the second one has 8, first one has 2, and your outside valence shell has 2 electrons in it. If you do, another example would be if I had nitrogen 7. So if I had nitrogen 7, my first shell can only hold 2. Alright, so how many more do I have after that? So 7 minus 2, I have 5. So my next shell can hold 8, but I don't have that many. So I have 5 here in my valence level, or my valence shell. Or shell, whatever you want to call it. Alright, 5 electrons in that. It's always electrons. Alright, the first kind of bond we're going to talk about is an ionic bond. In an ionic bond, you have to have ions. And what an ion is, it's a charged atom, basically. So it can be positively charged, or it can be negatively charged, depending on if it has gained or lost an electron. All right, since electrons are negative, if you have an atom that's an ion that's negatively charged, that means you have gained an electron. If you have a charged atom that is positively charged, that means you lost an electron. Because it is negative, now your protons take over here and it becomes positively charged. You gain an electron here, you have one more negative electron over your proton, so it becomes negatively charged. And you need this in order to have an ionic bond. So, let's see. This causes 2 ions to be attached to each other and bond. This is called an ionic bond. So, like with sodium and chlorine. Alright? So sodium sends over an electron to chlorine. Alright? It goes over here. That makes sodium, since it lost an electron, positively charged. That makes chlorine over here negatively charged because it's gained an electron. And because of that, it allows them to bond by an ionic bond and become sodium chloride. Metal and non-metal, so sodium chloride. This is a new substance when it bonds like this. It has new chemical and physical properties. So sodium and chlorine had their own, and now they become table salt. Very, very different. All right, just to make sure you understand this, these charged atoms are called ions. All right? To have an ionic bond, you have to have a positively and a negatively charged atom that combine and bond. So one will lose an electron and become negatively, the other one will be positively charged. Charged atoms are ions. They can be positive or negative, depending on if they gain or lose an electron. All right, in an ionic bond, the two atoms, one atom gave its electron to the other atom. All right, then they became negatively or positively charged, and they became ions when that happened. With a covalent bond, they actually just share electrons. There's nothing given up. Valence electrons, so those in the outer shell. So if I have, my example here is carbon. So carbon has 6 electrons. So it has 2 in its innermost shell. Then in its valence shell, because it's just the outermost one, it has 4 electrons. Now instead of sending it over, I can combine this with, now I take my carbon here, and I'm going to mix it with my fluoride. So fluoride is 9. So that means a fluoride is going to have 2 in its innermost shell, and then 7 in its valence shell, because it has 9 altogether. The second shell can hold 8. So there, put my innermost shell, give me 2 electrons. Now they're going to share 1. They're not giving or taking, they're just sharing one of the electrons. So here they're going to share this one. So 2 in their innermost and in their valence shell. So now they have 8 in their outside. This fluorine has 8 on its outside, which is what it wants. It wants its perfect octet on the outside, or perfect 8 electrons. So they're sharing that one. Now don't take my picture incredibly accurately. And there you go. Now this is a covalent bond because all they're doing is just sharing that, so they get the perfect 8 on the outside. And this was carbon and 4 fluorides, and it becomes carbon tetrafluoride, which is CF4. All right, carbon tetrafluoride. And this is a covalent bond because they are sharing, they are not giving it up. All right, and just like with an ionic bond and a covalent bond, carbon has its own physical and chemical characteristics. So does fluorine. When you combine them, they have new chemical and physical properties. All right, metallic bonding. So in metallic bonding, it's always between 2 metals. They don't share and they don't transfer electrons either. Instead, they create what is called a sea of electrons surrounding positively fixed ions. So the electrons is free to roam wherever it wants in this sea of electrons. And the last thing is noble gases they don't want to form bonds, because on the outside of noble gases, they always have a perfect octet on the outside. So they don't need anybody's electrons, and they don't want to give up their electrons because they have that perfect octet on the outside in their valence level. All right, this has been chemical bonding. Hope it helped. Good luck.